Hey guys, okay, that's way too dark. Come on now, there we go. That's much better. I'm noticing that little line. There we go. Man, why do I only realize that everything's going wrong after I already hit record? I don't know why that always happens. I hit record, and then I realized that my camera's dirty. I hit record, and then I realized that you're not going to be able to see anything. I don't know why that keeps happening, but it freaking does. Anyway. You guys... Oh, by the way, I cleaned out my microphone. You can probably hear me quite a bit better now. And it probably sounds a bit more trebly. You can hear more high-pitched stuff now. Like the S's and the T's and stuff. The kind of sounds. You can hear those a lot better now. It sounds a lot more trebly. And it's a bit louder. I cleaned out my microphone. That was the problem. If you guys were wondering why all my videos were so quiet, it wasn't because of puberty. It wasn't because my voice all of a sudden got really quiet because of puberty. No. My microphone was gunked up with crap. I cleaned out my microphone, and it's working better than ever. Anyway, you may remember from that, homemade power supplies video. I rebuilt those. I rebuilt my power supplies. This one was my 10 volt, and I found out it's not 10 volts, it's 6. It's 6 volts. What, Charlie, how the frick did you get that so off? Because my multimeters are not really accurate to stuff that doesn't have a load on it. So this output's only 6 volts. Frig, excuse me, but when there's nothing plugged into it, the multimeter says it's higher than that. And the rectifier part also messes with the voltage, because of the capacitor. This one, yeah, it's the one I called the 10 volt before. It's actually only 6 volts. And it's the AC/DC switchable one. So as you can see, it's completely different. The only thing that's the same is the position of the transformer. The transformer has not moved, but everything else has. So before, the switch for the AC/DC was like in there. This switch here was over here on this corner, and it was on its side. And there was a whole whack of wires over here. And the capacitor was behind the switch. So the switch was right here, like I said. The capacitor was like kind of behind it. And the diode was right in front of the AC/DC switch, which was right there. So they were all in completely different oh, and the output wires came out here. But now I moved that switch, I flipped it upright, and I put it there. So now you don't need to grab it to click it, because if you just pressed it and clicked it while it was sideways, it'd just break off. So I put it upright. So now you press it like a button. Oh, frig. I have a little bit of a cold, so I may sound a bit funny. And I'm often sniffling. Which sucks, because it's my birthday yesterday. Yesterday was my birthday. I just turned 16, guys. I cannot believe I forgot to say that at the beginning of the video. But yeah, I turned 16 yesterday. Not gonna be very long before I'm behind the wheel of a car, probably, but I'm not too sure about that. Ah, yes. And the AC/DC switch, I moved it right there. So now there's no wires in the way. It's not in between everything. You gotta stick your finger through every little part of the power supply to change that. No, it's right out in the open. Much easier to flick. And all the wires are glued down. Now the wires aren't all sticking up everywhere. The only sticking up wires is this little one here, which is the output before the switch. So this one goes to the switch. This little one goes to the switch, and that little tiny red one there comes out of the switch. So yeah. And this connection here. These wires are not glued down, because as you can see, they really don't want to go down. They want to stay up. So, I can't shove that down and have the wires break. No, frick that crap. Let's just let them stick up. Why not? It won't change. It won't hurt anything. And the diode is now right here. And the capacitor is right here. So this part here is the transformer area. And this part here is the switch. And this part here is your AC and DC switching area. And your output plug. But yeah, I rebuilt this one, and that's what it's like now. Why did I rebuild this one? I explained it before. It was not a good design. All the wires were sticking up everywhere. Oh, and you remember how it didn't like to go unless one wire was at a really certain place, and it often just turned off randomly. I fixed that now, because this time I soldered the connections instead of gluing them. Because now I've got a soldering iron. It's only recently that I got a soldering iron. That seems kind of strange, because electronics have been my thing for so long. And I've been always fixing electronic devices, taking apart electronic devices, making little electronic devices like these and stuff like that. And you're just like, it's obvious that he must have a soldering iron. Well, no, I did not. I actually didn't. It seems very strange, doesn't it, that I did not, that a tech nerd like me, who did so much stuff with electronics, did not have a soldering iron. Seemed kinda stupid. So yeah, but yeah, the only thing I had that could attach wires together was a glue gun, a hot glue gun. And obviously that's not very good, because glue doesn't conduct electricity. And it doesn't really stick to the metal. But now, I finally got a soldering iron. So, when I rebuilt this, I soldered all the connections and glued them over as insulation. You can probably see some soldering somewhere here. Right there. You can see a glob of solder there. That's probably the only connection there that's not glued over. Because, you know, it doesn't really need to be. And it doesn't move, so. It doesn't really need to be glued if it doesn't move. Because it's already glued to the ground here. But yeah, the only connections that I really glue are ones that move, like this. Because solder, yes, it connects your wires together. And yes, it gives you a great connection. And yes, the wires don't really want to untwist or anything. But now, but they still break. You'll bend your wire, and it'll snap off. And that end of your wire will still be in that glob of solder. And your wire will not be bared. That bared end just comes right off of the wire. So I glued them, so that they don't move, so they don't break off. I just realized that this is on. There we go. But yeah, however, all the electronics in this are exactly the same. The wires and the systems and everything have not been changed whatsoever. Everything's exactly the same. The only difference is they're all in different places. But all the wires, all lead to the same connections and everything. They're just in different places. So the switch still cuts off the very last output wire, and the rectifier here has not changed whatsoever. Every wire leads to the same connection that it did before. The only difference is that now they twist in different directions. And yeah, I am probably going to glue this little wire down, because it is kind of in the way of the switch there, and it will be annoying to repeatedly hit it every time you switch to DC mode. Oh, by the way, down is DC, up is AC. DC, AC. Man, I spent 11 minutes just talking about this one. Oh. Box of power supplies. So, only 2 of the power supplies in here are homemade. All the other ones are these. You know, plug-in-the-wall adapters. Where's my rectifier? Hold on a minute. Alright, I got my homemade rectifier. Ugh! Yeah, I've got my little LED powering device in my box of power supplies. And I've got 4 of these transformers. So, sometime, I might soon have 4 more homemade power supplies, because I could easily turn these into power supplies. I've got lots of diodes, I've got lots of switches, I've got lots of capacitors, and I get this cardboard from pizza boxes. So yeah, I'm probably going to have a lot more of these, the ones designed like this, where they have an AC-DC switchable. And I'm probably going to make them out of these transformers. Now these are your input wires. So this can turn AC into DC, so it can be a rectifier, or it can just be a switcher. Like, it can just add switches. It can just be used as an on-off switch. Frig. Hold on, I gotta blow my nose. That's much better. But yeah. So it can just be used as an on-off switch thing. If you plug AC current into here, it works as a rectifier. Now you've got your AC output, which is not rectified, it just goes through the switches. Because, you know, these adapters, they don't have switches. They do not have any switches. So, yeah, you just plug that into the input plug. Click, and there we go. Now this is attached to that, and you got your AC output. Now you've got switches, so you're able to turn it on or off with a switch, or a button on or off, so you can repeatedly press it over and over again. Do like short little bursts of electricity to like make a light flash on and off really quickly, or to make a motor just kind of go in small little bursts. And yeah, the DC output here does go through the rectifier. The rectifier in this one is a full wave, so it's a little bit better than this one. This one's only a half wave. It's got 1 diode in it. This one's a full wave. It's got a diode bridge right here. That black rectangle. I remember how I said it like that in a different video. I was trying to say black rectangle, and I just couldn't. And I was like, yeah, that's the diode bridge right there. That black rectangle. Why did I say it like that? That black Black! For frick's sake! Black rectangle! There we go! Do you remember that? That was in a different video I made. Battery, though. And yeah, so you plug that in there, got your AC output and your DC output. And it's got 2 different input plugs. So some of my adapters here, well, all of them except my AC ones, for some reason, have their own plug on the end instead of my custom plugs. They've got their own plug. This shape. This is a DC one. So I put a plug for that on it, and for some reason, just somehow, I don't know what the odds are, but somehow I was lucky enough for all my adapters to have exactly the same size plug. And yeah, now I can plug these in here. Now I've got on-off switches. So now both these are DC output. The rectifier doesn't really do anything in this one. They're both DC. However, this one, it's got a capacitor. So this one, when you turn it off, it'll be instantly off. But with this one, when you turn it off, it'll fade away. I wonder what it'd be like to have this, like one of my homemade ones here, plugged into my rectifier thing. that'd be pretty funny. That would that would actually be pretty neat. Because this one does not have like a flash button. It's got just one switch that's kinda hard to press. And this one, it's also got a flasher button. So it's got an on-off switch, so you can turn it on and it stays on, turn it off and it stays off. Or a flash switch. So I could literally hook this up to my homemade ones. Plug, and there we go. And now it's got a flasher switch. Now this huge mechanism here, well, it's not really huge, it's actually really simple, but all of this crap, diode bridge, tons of wires, button, switch, capacitor, glue, soldered connections, all of that, and all it really does is make it so you can flash it on and off when you attach it to one of my homemade ones. Because these have already got an on-off switch of their own. So the on-off switch here is pretty much useless. And since they already output DC, then the rectifier is pretty much useless. So automatically 2 things are completely cancelled out. Oh, and this one, since the switch cuts off the output, and it does not have that capacitor fade away effect, that's what this can add. This, if you output it, if you connect this one, this brick power supply to this, now, and if you hook it up to the DC output, now you've got a capacitor. So now it fades away when you turn it off. That's what that can be used for as well. So yeah, this thing has a lot of uses. This is a very useful little thing. I'm glad I made it, like, disconnectable. Because this was originally, I explained in a different video, that was originally, for this. I built that for this. Them black wires there were the same black wires as these. These were connected to this. But then, I cut the wires, and I put plugs on this, and I put a plug on this. So now, this was not attached to this, and you could attach it to anything else. And it was just so much more convenient. And yeah. This video was originally supposed to be about talking about how I rebuilt a couple of my power supplies. But I started talking about a lot of other stuff too. Now my other power supply here, my 12-volt one that I called it, it's actually 9. It's 9 volts. Yeet! it looks much nicer. Just like the other one over there. It looks much nicer after I rebuild it. This one looks so much nicer because I rearranged everything to be in a very nice order. Now nothing's in the way, and it's all arranged in a... Oops. And it's all arranged in a nice, even, like... sections. Transformer. Switch. What's it called? Rectifier. The transformer area, switch area, rectifier area. And it's in 3 different things instead of everything scattered all around everywhere. The design barely changed whatsoever. It's exactly how it was before. However, now, I used glue instead of tape. That one there was originally glued, but this one was originally held on by tape. It was pretty much just a huge layer of tape around the whole thing, holding everything in place. Now I used glue instead. It looks much nicer. And since I ran out of little plugs, this one does not have a plug. I need to get more of those. And yeah. But yeah, the design barely changed whatsoever. This one is the only one I've got with a removable wire. But yeah, this one's got a flasher switch of its own. However, it's different from this. This one, it only works when it's off. You turn the switch off, and then you can use the button. You press the button and it's off, you let go of the button, or you press the button and it's on. You let go of the button, it turns off. When with this, that flasher switch only works when it's on. That flasher switch, you press it and it turns off instead of it being like on, off, it's off, on. So to make it go flash, 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 flash. Instead of doing, here you go. But yeah, that flasher switch comes after the main power switch. Well, it comes after everything. This cuts off the input, this cuts off the output. So, the power goes from the wire, goes in there, and it goes through the switch and to the transformer. So this cuts off the input of the entire power supply. And it goes through this, and go to the transformer, and it goes through the rectifier board, and then it goes through the flash switch, and comes out the wires. So yeah, there's a switch on the very beginning and the very end of the power supply. And this one, it's only got a switch at the very end. And this one, the switches are kinda in the middle. So when you've got a power supply plugged in, the switches on that are cutting off the output of the power supply, but the input of the rectifier. So these switches are in between the power supply and the rectifier. They're in between. So in that, the switches would be like on these wires here. These come out of the transformer and go to the rectifier. These are your 9-volt AC wires. You come out of there and go to the rectifier. If the switch was here, it'd be the same as this. And yeah. Oh, I said a bit ago, it slightly changed. I said it was barely modified whatsoever. I didn't mean it was not modified whatsoever. It just was barely modified whatsoever. There's just one tiny little change. Well, other than the fact that it's glued and not taped. But there's one little change. That input thing. It uses a different wire now. There's the wire. So it's very similar to its old one, just different now. The old one did not have those bumps in it there in the middle. Now it's got to be bumped because it's got, you know, the bumps in the plug there. So it's got to be this type of plug in order to go in. And now, the reason I had to change that plug is because this one was so cool. Because it's got an outlet on it. So, what does that mean? You're able to plug in the power supply and then plug in another power supply to it. There we go. Now we've got two power supplies hooked up on one outlet. One power supply is literally being powered by the other power supply-ish. Kinda. It goes into the power supply, but then comes out and goes to another power supply. So it's got two power supplies in parallel. So yeah, you're able to plug in the power supply and then have another power supply plugged into it. That's pretty freaking cool. Sadly, it can only be this power supply. This is... this second homemade one here is the only power supply that you're able to plug into this. Because it's the only other power supply I've got that has this plug. All my other power supplies are adapters. This can't fit on there. Yeah, no, it can't. It doesn't fit. It's too big. The plug down here is blocking it. Frick! Come on! There we go. Goodbye.